Alright, so in this question here, or this example here, we're going to be graphing a piecewise function, and this piecewise function has two different parts. One of them is just going to be a linear subfunction, and the other one is going to be absolute value. And we're going to be graphing this by using our transformation rules. So let's go ahead and look at our first subfunction of 3 times the absolute value of x minus 4 minus 3. So let's just go ahead and just identify what our different transformations are here. So our first one, our 3 out in the front, that means we are going to have a vertical stretch of 3. And because we have nothing that's factored out as a horizontal stretch or compression on the inside of our absolute value, we can kind of think of 3 as our slope in this example. Next, we have our x minus 4. Minus 4 inside our brackets, inside of parentheses, inside anything. If it's in the inside, we do the opposite. Normally, we think because it's negative, we'll go to the left, but we're actually going to be going to the right 4. We have a horizontal shift to the right 4. And then lastly, we have our minus 3. That goes as we see it. Minus 3 means we are going down 3. And so this will give me my vertex of my absolute value. This will also give me my slope. So if I go ahead and point or plot the point 4 comma negative 3 based off of my transformation rules, that will give me the point right here. And then again, I know my slope is 3, so I'm going to be going up 3 over 1, like here, and like right here. Now let's also pay attention to our domain restraint or restriction. That's at x is greater than 2. So these points here are all good. Now I'm going to be going in the opposite direction for my absolute value to make my v. So instead of going, I'll have my negative slope. So that would be this point here. And then this point would be right here. Now again, because it's just a greater than, that means we're going to be having an open circle because 2 would not be included. So at this point right here, 2 comma 3, I'm going to put my open circle just to represent that. And I'll go ahead and just fill out the rest of this and then connect these with a line to just graph the first part being my absolute value. So that would be graphing my first subfunction here. Our second one, we're going to go ahead and follow the same exact train of thought. We have our linear equation given to us in a point slope form. So that means that this right here, this negative 1/2, that's going to be my slope. Again, my point is going to be located, that's referencing at 2. It says negative 2, so that means we're going to the right 2. Just like how in our absolute value, minus 4 meant right 4. And then down 4, minus 4 would be down 4. So that means I know my vertex, or not my vertex, my point on this line that we're referencing is going to be at the coordinate 2 comma negative 4. So I go there on my graph, 2 negative 4. Now, when I type this, I actually meant to put an or equal sign underneath this. So we're going to do that now. So we should have an or equal sign here, which x is less than or equal to 2. So that means at 2, I should have a closed circle because, again, that's or equal to. I'm actually going to go back and do some blue just so I can make these match up. So I should have this as a closed circle at 2. Then I have my slope. My slope is negative 1 over 2. So usually that means going down 1 to the right 2. But if we kept doing this, we'd see we'd go into x's that are greater than 2. Now instead of going down 1, right 2, I can go in the opposite directions. I can go up 1 and left 2. That would give me the same slope. And so I can go ahead and plot those points. I'll erase the ones that aren't in my domain and then connect these with our line. So I would have a graph piecewise that looks like this. And again, for this, I can assume it's going to go on forever here, and this is going to go on forever this way here. So that would be how I would go ahead and I would graph my piecewise function that's given to me using my transformation rules. You also can go ahead and make a table, or you can go ahead and draw them both completely in an erase based off of our domain restraints. Those all both work. So lastly, we're going to go ahead and do our domain and range. Again, our domain is all of our x values, starting from the left with an arrow that goes all the way to our closed circle where it stops here. But even though we have a point of discontinuity here, where this circle is closed, this one's open, so we can go ahead and pick back up, and it goes on until we see another arrow going all the way to the right. So that means our domain for this piecewise function would be all real numbers, or negative infinity to positive infinity. And then lastly, we have our range. So our range is all of our y values, and we start at our lowest possible value. We start at -4 with a closed circle here. And then when we go up, we see we have a gap between this point and this point of our other subfunction. But because we have overlap here and this line covers that gap, we don't have to worry about that because that means that we're going to have y values that are included in this area. And this line, even though it's kind of flat, will go up forever. So we're just going to be going from the range of -4 to infinity. And so again, that would be how we would graph a piecewise function and then also find its domain and its range.